Annuities pricing and mortality tables. What determines the price of a life annuity? That is, what determines how much monthly income an insurance company will give you in exchange for, say, $100,000? As we address this question, keep in mind that insurance companies are trying to charge a price that compensates them for their costs and also to leave some cushion of profit. Of course, if one company prices the product with a high profit, another can undercut them, so it is at least a somewhat competitive market. An insurance company that needs to price an annuity has a similar problem to an individual who is trying to set up a stream of lifetime income for him or herself. Imagine that you wanted to pay yourself $500 per month for life out of your savings. Suppose, for the sake of argument, that you knew how long you would live, say 30 years. And instead of each year consisting of 12 monthly payments starting next month, let's suppose you were just going to get $6,000 per year starting a year from now. So $500 per month times 12 is $6,000. If you were doing this in 2013, your first payment would be in 2014 and your last in 2043. Well, then there are safe securities you could buy to replicate this stream of cash flows. Those would be government bonds that look like this. To meet the 2014 cash flow, you would buy a zero-coupon bond that will pay $6,000 1 year from now. To meet the 2015 cash flow, you would buy a bond that will pay $6,000 2 years from now. To meet the 2016 cash flow, you would buy a bond that will pay $6,000 3 years from now, all zero-coupon bonds, and so on through 2043. These government bonds each have a price, and if you learn something about bond pricing, it is not hard to determine what these prices would be. To replicate the cash flows, you basically need to buy 30 bonds with different maturities, and the cost of buying those bonds would be the cost of paying yourself a riskless benefit. Now, some might look at this and think, gee, it seems expensive to do this with riskless securities. Can't I just set aside less money and take some risk? Well, that's all well and good if you are willing to receive less from your investments than you've planned in case the stock market or other risky asset you invest in does not perform well. But when an insurance company writes a contract with you, they're going to have to make that specified payment no matter what. An insurance company that promises riskless benefits and funds them with risky securities exposes itself to a risk of insolvency. As a result, insurance companies are regulated. They're allowed to take some risk in their portfolios, but under law, their rights to take that risk are limited. Otherwise, people could buy annuities from the insurance companies and find that the insurance companies become insolvent before they can make all the payments. What about uncertain life expectancies? Insurance companies are selling annuity products not just to one person, but to a pool of individuals. If that pool of individuals is large and has the same longevity and mortality characteristics as the rest of the population, then the company can make a pretty good forecast of the bonds it would need to set aside to make the payments. Let's consider an extension of this example. Imagine a hypothetical population that lives on a planet called Snorf. Now, instead of having human mortality patterns, each member of this species, call them Snorfs, either dies at age 80 or at age 95. That is, if a Snorf lives beyond 80, he will surely live to be 95. So half of the Snorf will live to 80 and half will live to 95. Suppose further that the Snorfs in this population do not know of which type they are, and that there's no medical test that would reveal that type. Finally, let's suppose that there are 100,000 Snorfs in every age cohort, which is to say that every year 100,000 Snorfs are born, and therefore every year 100,000 Snorfs reach any given age up to 80. In this case, if every Snorf were required to buy an annuity from an insurance company on the planet Snorf when he reached age 65, then the insurance company on the planet Snorf could pretty well buy bonds that would cover the entire liability. For every new cohort of Snorf reaching age 65, the insurance company would just buy, 100,000 of each of the zero-coupon bonds that matured in years 1 through 15, plus 50,000 of each of the zero-coupon bonds that matured in years 16 to 30. Note that we don't know today which exact Snorfs in this population are going to be the ones to live 15 years from age 65 versus 30 years from age 65. We just know that half of them are. And that is sufficient for the insurance company who is pooling these risks to buy the necessary securities. We can also define for this population a mortality rate, also known as a death probability. For this population, mortality is 0 until the age of 80, at which point it spikes up to 50% during the year the population turns 81, after which it returns to 0 for a while, and then finally spikes up to 100% at age 95. Now let's return to Earth. The population I just described is of course a rather unusual kind of population. But of course, actuaries who work for insurance companies and the government calculate death probabilities for humans as well. These actuaries produce statistical tables which, depending on whether you're a glass half full or glass half empty kind of person, are called either mortality tables or life tables. Here is some data based on the life table for 2007 produced by the Social Security Administration. This is based on a particular kind of mortality table called a period life table or period mortality table. It shows the death probabilities by age that are actually being experienced by people today, or in the case of this table, around 2007, for essentially everyone in the U.S. and U.S. territories, so covering currently around 320 million people. I've put the plot on a logarithmic scale so that even small differences are apparent at all ages. A period life table does not account for the fact that life expectancies are changing over time. So for example, today's 75-year-old men have a mortality rate of 4% in the year that they are 75, which is really not bad. But if you're 25 today, it may well be that when you turn 75, your mortality rate will be a lot lower than 4%. And conversely, if today's 75-year-old man had opened up a Social Security period mortality table in 1960 when he was a young man of 22, he would have seen that a 75-year-old in that period mortality table had an approximately 7% mortality rate. And he might have mistakenly concluded that his life was likely to be much shorter than it is in fact likely to be. Death rates across the age distribution were in fact a good deal higher for men in 1960 than today. And here are some similar data for women. In the 2007 period life table, 75-year-old women faced mortality rates of just under 3% in a year. In 1960, the 75-year-old woman faced an almost 5% likelihood of death in that year. And as was the case for men, death rates across the entire age distribution were a good deal higher for women in 1960 than they are today. So the bottom line so far is this. While today's period mortality tables present the experience of people of a given age today, they do not present the experience that you can expect to have at any age that is different from your age today. This raises the question of whether it is possible to construct a mortality table that projects mortality rates for someone who was born in a given year. For example, someone born in 1980. That is what a cohort mortality table does. Here, demographers and actuaries are employing their best possible projections of how long people will live given improvements in mortality that are likely to occur. So you can compare, for example, the projected mortality experience for someone born in 1980 who turns 34 years old in 2014 with today's period mortality tables. You'll see that the people born in 1980 had higher mortality rates when they were young kids than today's young kids, but they will have lower mortality rates beyond around their current ages, which is in the early 30s. Now, a really tantalizing calculation you can do with cohort mortality tables is to see the cumulative survival probabilities of people of different ages. So here's the entire cumulative probability that males and females born in 1980 make it to any given age. For this cohort, again, these are people who are in their early 30s today, there is around a 75% chance that a man will live to be 70. There's a 54% chance they'll live to be 80, and a 21% chance that he will live to be 90. And there's around an 83% chance that a woman will live to be 70, a 65% chance she'll live to be 80, and a 33% chance she will live to be 90. We can also ask the question of survival probabilities conditional on attaining a given age. For example, assuming a person born in 1980 eventually reaches age 65, what will be the remaining median number of years he or she will live? And what will be a 10th percentile outcome? And what would be a 90th percentile outcome? Well, if you're a man born in 1980 and you make it to age 65, actuaries believe you have a 90% chance of living beyond age 70, a 50-50 chance of living beyond age 84, and a 10% chance of living beyond age 95. If you're a woman born in 1980 and you make it to age 65, actuaries believe that you'll have a 90% chance of living beyond age 72, a 50-50 chance of living beyond 87, and a 10% chance of living beyond age 98. Perhaps living to such advanced ages seems to you as though it would constitute good fortune, but it won't be such good fortune if you have no assets on which to live. Finally, we can look at how these cumulative survival probabilities have changed over time. Let's start with a cohort born in 1950 who will turn 65 in 2015. These are data that an insurance company would want to use if pricing an annuity product for someone who was buying an annuity at age 65 in 2015. At most points of the distribution, it's about 2 years shorter than in the people born in 1980. And now looking forward in time, for the kids born in 2010, it's about 2 years longer again. Indeed, a girl born in 2010, if she lives to be 65, has around a 10% chance of living to be 100 years old. And these odds are projected to keep rising for future generations. Now, of course, in a population as diverse as the population of all U.S. citizens, there is substantial heterogeneity in longevity. Life expectancy appears to vary by income. It also appears to vary by race. And while healthy people can, of course, die suddenly and unhealthy people can live a long time, your doctor could probably give you a reasonable sense or estimate of whether you're likely to live longer or shorter than the average for your age and sex. So this means that annuities are going to be a better deal for some people than for others in the population. The longer you think you'll live, the better deal an annuity will be. For the insurance companies, on the other hand, the only thing that matters is whether the mortality tables they are using for their pools of customers are correct on average. If they're not, then insurance companies will have unexpected variation in their profits for selling annuities. If the population ends up living longer than expected, say because cancer is cured, some insurance companies may experience large losses on the annuity products they sell. On the other hand, if the population ends up living shorter than expected, then the insurance companies would experience gains on the annuity products. And a related concern that insurance companies surely have is whether the population of customers arriving at their door is really the average in the population. That is why they will use life tables specific to the assumed distribution of their customers in pricing their annuity products. So in this segment, we examined why the price of annuities depends in part on the mortality patterns in the population. A single life annuity can be thought of as a bond that makes interest payments only if the individual is still alive, with the principal ultimately forfeited upon the purchaser's death. In a pooled population, then, a life annuity is a bond whose expected payouts depend on overall longevity. The value of such a product can therefore be pinned down by the factors that determine two things: 1, bond prices, and 2, the distribution of longevity in the population.